In this video, we're going to continue our discussion of electrical distribution for most often residential and light commercial. I think there's a few commercial three-phase applications tossed in here. But the breaker panel and the disconnect is important for you to understand because you have to have good power coming to the equipment before you can start to diagnose and work with existing equipment in a building. So a breaker panel consists of you have your breakers, and usually in two rows. You might have you'll have a neutral bus bar over on one side sometimes, or on the bottom, and you'll also have a ground there. It's important to realize that most air conditioning technicians in most states are not allowed to do anything inside the breaker panel. The disconnect is completely different. It's on the external side of the building, and it is your point of connection for air conditioning condensers into the main system. Usually anything from the disconnect back to the panel is you have to have an electrician take care of. From the disconnect to your equipment, you're allowed to deal with. So there is a point of delineation here with respect to your licensing. It's very important to check with your home state or the state you're working in to make sure you know exactly where an electrician is required and where you're allowed to work. So the breaker panel, the function of it is to distribute electricity to individual circuit. Each branch has a rated amperage. Breakers must be reset by hand. The main breaker will control the voltage to the whole panel. So again, if a breaker trips, okay, you're going to have to turn it off and back on by hand. Each breaker can only have one line coming into it. The double pole breakers are the 240 volt breakers, and they actually connect to both buses, L1 and L2. Panels can be built with or without a main breaker. They're rated for amperage, how many amps the main lug can handle, and then that translates into how many amps the main breaker can handle. They are they're constructed for phase. There's a panel for single phase and there's a panel for three phase. You can take single phase in a lot of cases off of a three phase panel. The neutral strip is with screws. There's a ground strip with screws. Each breaker should be marked, and you need to be able to lock them out for safety. Breakers will be single pole, double pole, and in the case of three phase, three pole. They either snap in or clamp on. They have three positions. They're on, off, or tripped. When a breaker is tripped, the handle will usually move halfway between the on and off position, or a red mark will appear. To reset this, the breaker must be moved to an off position and then back on. This is an example of a single pole, a double pole, and a triple pole breaker. The single pole is going to be 120 volts most often. The double pole is going to be your 240 because it actually connects to L1 and L2. And your triple pole you will only see in a three-phase circuit and a three-phase panel. This is an example of another type of breaker. This is a GFCI breaker. This will provide ground fault to the entire circuit. You also now are seeing these with arc fault, okay, so that if there's an electrical spark or an arc someplace in the circuit, it will trip the breaker. In many states, they're now required per electrical code, depending on if the state has adopted the new code or not. They're required in any arc faults are required in any circuit that feeds a bedroom. Lots of times it's now any lighting circuit or any place where people are sleeping. All systems have to have another means to disconnect power. Okay, this is all mechanical systems. It has to be within the reach of the technician. It can be mounted to the outside of the unit, and it uses double pole throw to 208, 240 applications. single volt for 120 volt applications. In other words, you need to be able to disconnect all power from a unit within arm's reach of that unit. It can be fused or non-fused depending on the application. It may have a lever or a pull-out. This is an example of a disconnect. It's a square D that has a lever on-off. You see this a lot of times on larger rooftop systems. You can also see it on residential. This is the type where you open the cover and there's a pull-out. Okay, has an on-off. You put it in one direction for on, you turn it over and have it upside down for off. These do corrode. You have to watch for the points breaking off. Here's an example. Okay, the normal look is this, and over time, weather will start getting to them, and it could actually pull out and leave one side of the terminal in the system. Okay, so you do need to check with your meter even after you pull these out to make sure it has actually disconnected. This is a fuse type. Your pull out that I just showed you goes on the top here. Okay, and then there's a fuse on L1 and L2 that protects the equipment. Again, pull out type here, there might be fuses hiding up behind it. Note how these are connected. Okay, you have voltage coming into it down here, goes to L1 and L2, and then you have L1 and L2. Don't connect L1, L2 to one side or you'll have a direct short. There's several types of wiring you're going to see: EMT, Greenfield, Seal-tite, Romex, BX, MC, and old knob and tube. Number 7, we don't see that often anymore. Okay, EMT is electrical metallic tubing. It's rigid galvanized metal conduit. It can be bent and have wires run through it. Greenfield is a flexible metal conduit. No wires inside. The wires are provided by the installer. In other words, you use this, you cut it to length, you install it, and you run the wires through it. Seal-tite is a flexible conduit. It's used outside to provide weatherproof connections from AC condensing units to disconnect switches. It can be purchased as a whip, usually 6 foot long, with the wires and all the connections. This is an example of seal-tite. Notice it has specialized connections on the outside here. There's a washer under that nut. That nut comes off. You put this into the disconnect of the unit, put the nut back on over it, tighten it up, and then you connect your wires. Romex, the trademark name is NM of a non-metallic cable. Wiring, it's usually found in residential indoor applications. It has solid wire, plastic sheathing, usually with a ground wire that is uninsulated inside. SJ cord has stranded copper wire. It's rubber insulated. It's for use with portable tools and equipment. It's not for use for anything permanently installed. It's not allowed to be run inside walls. BX, it's a generic term for flexible metal conduit with wires inside. Comes from the store with wires inside, but it does not have a ground wire. The sheathing itself was used for the ground conductor. So you'd connect your L1 in neutral or L1, L2, and the metallic sheathing would be your ground conductor. MC is metallic metal-clad cable. It's flexible metal conduit. Comes from the store with wires inside, including an insulated ground wire. It's more durable and resistant to damage than Romex is. Now, knob and tube wiring, it's found in very old homes. It cannot be used. If you need to connect into it, you have to have it upgraded by an electrician. The wiring is run from knob to knob, uses tubes. You can see it here, uses tubes to go through any penetrations to protect the penetration. There's very little insulation on it, and it is a fire hazard. So if you find it, do not connect into it. Has to be upgraded. And just a closer look of how this goes, okay? from point to point, this uninsulated wire would just be stretched. Okay, when it needed to make turns or needed support, it would go into the knob that would be tightened down on top of it. If it had to go through a penetration, it would be put into a sleeve, which is the tube, and would be going through the penetrations. Again, old wiring, do not use it. Okay, so we have our breaker panel again. This is a rather full breaker panel. Be very careful when you're working inside a panel. This panel is obviously disconnected because this gentleman has his fingers into the metallic connectors of the cables. We would never want to do that. The main the main power coming in from the power company is right here, up here at the top. This is an example of a disconnect mounted on the outside of a building. Okay, so again, we have our breaker panel. The breakers snap in. You see that that's what this gentleman is doing, snapping a breaker into a panel. Again, there's no power on this panel, or this gentleman would not have his hands in here like this. It's an extreme shock hazard. Have to be able to disconnect and lock out. Do not forget, lock out, tag out. If you cannot see that panel, if you're working on equipment, or if you have any doubt whatsoever, the rule is you have to lock it out. And just as a reminder, you have an L1 and L2. 120 volt breakers connect into one of them. Either side, they're normally balanced. 230 volt will go across all. So disconnects and breaker panels are primary safety points. Even if you shut it off, always go back and check with your meter to make sure you don't have power on the equipment. Sometimes things are marked incorrectly. Sometimes disconnects might have other things shoved into them. And sometimes fuses have been replaced with things like pipes and other metallic objects. So always be careful, always check.